true projects. In this video, we are going to explain about a project titled Cursive Test Recognition in Natural Scene Images using Deep Convolutional Recurrent Neural Network. Tests present in images of natural scenes hold the valuable information with diverse real-world applications, spanning from automatic license plate recognition and the content-based image retrieval to aiding the visually impaired individuals, assisting the robot navigation and deciphering the street sign. However, effectively extracting the text from these images remain intricate primarily due to the factors like intricate background, test size variation, colors, orientation, low resolution, occlusions, environmental noise, and blurring. Recent strides in the deep learning have sought to surmount these challenges, and the natural scene test recognition through the bulk of advancements have predominantly centered around the Latin script. Cutting-edge techniques such as convolutional recurrent neural networks have emerged as a potent tool, demonstrating the remarkable prowess in recognizing the handwritten and the printed Urdu text. Despite the progress, the realm of natural scene test recognition continues to beckon further exploration and the innovation to accommodate the intricacies of diverse scripts and enhance its applicability across a plethora of domains. And presenting an innovative solution for the cursive test recognition, our approach revolves around a segmentation-free methodology that harnesses the power of deep convolutional recurrent neural network. And our focus centers explicitly on the complexities recognizing of cursive test within the natural scene. Our model comprises of three key components of CNN, RNN of with CTC mechanism that seamlessly transmutes the predicted sequence into the target labels. We extensively evaluate our proposed method on an expansive benchmark dataset containing the cropped images of the Urdu words. Within the real-world settings, this novel approach holds the potential to significantly elevate the accuracy and the efficiency of the cursive test recognition, particularly catering to the intricacies posed by the Urdu script and the natural scene images. And these are the basic requirements that are needed to build this project. The software requirements are Python IDEL with version of 3.7, Anaconda with version of 3.7, Jupyter Notebook. Hardware requirements are operating system as Windows, processor of minimum Intel i3, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. The first one is importing the packages. We need to import the essential libraries and the frameworks such as PyTorch, NumPy, and Flask to lay the groundwork for implementing the test recognition model. And the second one is exploring the dataset. Conduct a comprehensive exploration of the dataset containing the cursive test images, gaining the insight into its composition, labels, and the potential challenges within it. And the next one is image processing. Perform the pre-processing on the dataset, including the resizing, normalization, and the noise reduction to enhance the image quality and prepare them for the model training. And the next one is data extraction using ground truth. Extract the relevant data from the dataset utilizing the ground truth annotation to obtain the accurate label for the cursive test images. And next one is splitting the data into the training and the validation set. Divide the data set into the training and the validation subset. Training data will be used to teach the recognition model, while the validation data will aid in evaluating the performance. And the next one, building the model. Here various models are built. The first one is ResNet 18. It is a convolutional neural network architecture known for its depth and the skip connections, which mitigate the vanishing gradient problem during training. In the context of the test recognition project, ResNet 18 can be utilized to extract the hierarchical feature from the cursive test images. It moderates the depth, strikes a balance between the model complexity and the efficiency, making it suitable for capturing the relevant test pattern, fine-tuning the ResNet 18 on the test recognition dataset. And the next one is ResNet 34. Similar to the ResNet 18, ResNet 34 is a deeper architecture with increased capacity to capture the intricate feature. By employing the ResNet 34 in the test recognition project, the model can potentially discern the more complex pattern within the cursive test images. The additional layers in the ResNet 34 may aid in differentiating between the various styles and forms of of the cursive writing, contributing to the improved test recognition performance. And the next one is VGG16. It is characterized by its simplicity and the uniform architecture comprising the multiple convolutional layers and the max pooling layers. It applied to the test recognition task, VGG16 can efficiently extract the hierarchical feature from the cursive test image. It not as the deep as some other architecture, its stacked convolutional layers offered the potential to identify the salient test characteristics and contribute to the accurate recognition robustness. VGG19. It is an extension of VGG16 with even more convolutional layers, allowing it to capture the increasingly complex features. Integrating the VGG19 into the test recognition project provide a richer understanding of cursive test by leveraging its deep architecture. Its ability to process the fine-grained details could be particularly beneficial for deciphering the intricate elements of cursive writing style. And the next one is MobileNet V2. It is designed for the efficient inference on the mobile and embedded devices, featuring the lightweight depth-wise separable convolution within the context of test recognition. MobileNet V2 can provide a trade-off between the model complexity and the inference speed. Its architecture can efficiently capture the essential feature from the cursive test image while maintaining a compact design, making it well suited for the real-time recognition application. And the next one is user upload the image for analysis. Design a user-friendly Flash-based interface for the user to upload the cursive test image they want to analyze it. And the next one is trained model is used for predicting the user input image. Utilizing the trained recognition model to predict the content of the user uploaded image, apply the selected model architecture to interpret the cursive text present in the image. And the next one is predict the model for outcome. Present the model prediction outcome through the initiative front-end interface, showcasing the identified test from the user uploaded image. And the last one is final outcome is displayed through front-end. Present the model prediction outcome through the initiative front interface, showcasing the result to identified for the user uploaded image. And the execution of the project. To execute the project first, we need to open the code folder. And this is the code folder containing of various files within it, the results folder containing of the images that will be used to test the performance of the model, and the template folder containing of the HTML documents. It typically include of graph, form, index, sign-in, sign-up pages within it, and the static folder containing of the image folders like of images, results, CSS and JavaScript files within it. And the app is an py file which likely contains the information related to the front-end logic. It includes the code written in Python that handles the server-side operations such as processing the user request, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And the notebook is an IPYNB file which contains the combination of code, graph, and output all in one place. It allows the user to write and execute the code in the individual cell, making it a popular choice for the data science. And the signup.db is a file appear to be the database file used to store the user information. And for the execution of the project, first we need to copy this code folder and then open the Anaconda prompt. Here we need to write a command cd space and paste this code folder path. By this it will change the country directory to the code folder's path, and then click on the enter button. Here we need to write a command that is python space app.py. By using this command, it will execute the Python script and perform the runtime check for any syntax errors or the logical issues. And then click on the enter button. After running this app.py file, the Flash framework will host the application locally at the default address like this. We need to copy this link and paste it on any of the web browser of our choice, and I prefer to use the Google Chrome. I'm pasting this link and then click on the enter button. Here we can see the title and some information about it, and then click on the sign up button. Here it will redirect to the sign up page containing of some necessary details that are need to be filled to create an account. But my account is already created, that's why I'm using the sign in button. Here it redirects to the sign in page containing of username and password, and we need to fill those details and then click on the login button. Here it redirected to the index file containing of choose file and submit button. Click on the choose file button. Here it will redirect you to this folder and containing of various images, and we need to select one and then click on the open button. And then click on the submit button. Here it will redirect you to the result page and giving the prediction as of the Race for Life Cancer Research UK. And by using the try again button, here we can redirect it to this page containing of the choose file and submit buttons by clicking on the choose file and then selecting one and then click on open button and then click on the submit button. Here it will redirect to the result page and it giving as a result of. In this way we can detect that it. And in conclusion, we propose a segmentation-free method based on the deep convolutional recurrent neural network to solve the problem of recursive test recognition, particularly focusing on the test and the natural scene. The proposed model is based on the different components of VGG16, VGG19, VSNet 18, VSNet 34 to extract the more appropriate test feature and compare the recognition result. The experiment results show that the proposed model will be performed well when compared to that of other models.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.